Hey everybody, in this video we're talking about the non-routine question number 2 from this week. Please make sure you attempt this on your own before watching the video. So we have a polynomial, it's listed right here, and it's divisible by x minus 4, and we want all of the roots to be integers, and then we're looking for m. Well, since I know that it's divisible by x minus 4, I know then 4 is an integer. 4 is going to be divided into it. So, meaning that x minus 4 is a factor. So using the factor theorem, I'm going to plug 4 into x. So we have 4 cubed minus 4 squared minus m squared plus m times 4. And then we have plus 2m squared plus 2m plus 2. Oh, I'm sorry, that's supposed to be, that should be a 4m. There we go. Okay, so then I'm just going to simplify. So I'm going to have 64 minus 16, and then I'm going to bring in this 4, but also incorporate this negative. So it's going to be negative 4m squared minus 4m, and then plus 2m squared plus 4m plus 2. So from there, I'm going to combine like terms. So my numbers are here. I'm going to get 50. My m squareds are here. I'm going to get negative 2m squared. And then I have an m here and an m here, and those will cancel. Okay, so what am I going to do with this expression now? This is what g of 4 equals. Well, I want my roots to be integers, meaning I don't want a remainder. I want my remainder to be 0. So using the remainder theorem, I know that this has to be 0. And I'm going to solve for m. So I'm going to add my 2m over, 2m squared. And I'm going to have 50 equals 2m squared. Divide by 2, I get 25 equals m squared. Okay. And I'm going to take the square root. And I have plus or minus 5 equals m. So because we have two answers here, m equals 5 or m equals negative 5, we can only have one value for m. I want to check to see which one's going to work, okay? So I'm going to come back up here, and if I plug in, let's start off with if m equals negative 5. Let me erase, pause. Okay, so we have m equals 5 and m equals positive 5. We want to test to see which one's going to work. So I'm going to plug in m into the equation, to the polynomial up here. So g of x equals x cubed minus x squared minus, I'm going to plug that 5 in. 5 squared plus 5 times x plus 2 times 5 squared plus 4 times 5 plus 2. Let's do some math. That's a 3. So 5 squared plus 5, that's going to give you 30x. And then you're going to do 5 squared times 2. That gives you 50 plus 20 plus 2. That's 50 plus 20 plus 2, that's 72. Okay. So we're saying now that we have g of x here, okay, and this is divisible by x minus 4. That's what we started with, right? They're saying that it's divisible by x minus 4. So let's divide it and see what we get left over. So I'm going to do synthetic division. So 1, negative 30, 72. That's a 3. Bring down the 1, you get 4. You get 3. You get 12. Add those together, you get 18, negative 18. Multiply 4 times negative 18, you get negative 72, and you get 0. Okay, so then the question is, our new expression, which is x squared plus 3x minus 18, does it have roots that are integers? Okay, are there roots integers? So what are factors of negative 18 that adds up to 3? Well, negative 6 and 3, well actually positive 6 and negative 3, right? That'll give me, yeah. So these roots are integers. Okay? So 5 works, which means I'm assuming that -5 does not work, but let's check it just in case. Okay? So let me erase and come back. Okay, so I made all my 5's negative, and now we're going to simplify this math. Then we get x cubed minus x squared. We're going to get 25 minus 5, which is 20x. Okay. We're going to get -5 squared, still 25, times 2, that's still 50. Now that's minus 2, and that's plus 2. Okay. So here we have x cubed minus x squared minus 20x, and that's going to be 30 plus 2, so now it's plus 32. Oh, sorry, that should be a 3. Okay, so we're going to divide this by x minus 4 again. So we're going to synthetically divide 4, and we're going to get 1, -1, -20, 32. Bring down the 1, we get 4, we get 3. We get 12, we get -8, we get -32. And our expression is x squared minus 3x minus 8. So now the question is can we get integers when we solve for this, right? When z equal to 0 when we solve. So factors of -8 that add up to -3. There's 1 and 8, there's 2 and 4. There aren't any. So we'd have to use the quadratic formula, which means we're going to get irrational. So -5 does not work. So the answer for the 19 question is m equals 5.